Hi everyone, hello, how are you doing? I hope everyone is doing good. So, welcome to another video of respiration and circulation. Up till now, we have discussed the mechanism of respiration, and also we have discussed the factors affecting the exchange of gases. So, in the previous video, we talked about the solubility of the gas, then the pressure concentration, the concentration gradient of the partial pressures of oxygen and carbon dioxide, that determines the exchange of gases between the tissues and the blood and the alveoli. Then the thickness of the alveolar membrane and the solubility of the gases, the transport of the oxygen and carbon dioxide uh, with the blood, that is the hemoglobin that is responsible for taking the oxygen and diffusing it to different parts of the body. So all those factors we discussed in the previous video. Okay, that depends, that determines the exchange of gases between alveoli, blood and tissues. Now in this video, we are actually going to discuss the oxygen transport and the carbon dioxide transport, how oxygen is transported, how carbon dioxide is transported, in which form. Okay, so let's begin. We first begin with the oxygen transport. You don't have much information in oxygen transport. Oxygen transport is basically, as we discussed in the previous video also, that the red blood cell which is there, it has RBC in it, and the RBC has hemoglobin in it, and this hemoglobin is responsible for binding oxygen, and once it binds, it now forms something known as oxyhemoglobin. Okay, so oxygen is transported from the lungs to the tissues in two forms. Okay, oxygen is transported from the lungs to the tissue. So you inhale air, oxygen rich air, the oxygen reaches the alveoli. The oxygen will now diffuse from the alveoli to the tissue. So this transport now can be, okay, so the alveoli transfers, diffuses oxygen into the blood. So the blood takes the oxygen to the tissue. Okay, now this blood taking the oxygen to the tissue, it can take the oxygen in two forms. Okay, one form is the oxyhemoglobin form, as you can see in the slide, and the another form is dissolving the oxygen in the plasma, which is only 3%, whereas the binding form, the oxyhemoglobin form, roughly 97% accounts for this type of transport. Okay, so each hemoglobin molecule in the RBC is capable of carrying how many oxygen? 4 oxygen. Each hemoglobin molecule is capable of carrying 4 oxygen molecule. It will carry 4 oxygen molecule from the blood. I mean, it's there in the blood from the alveoli. Okay, the oxygen diffuses into the blood. So you have the oxygen molecules. Oxygen molecules diffuses into the blood. You have the hemoglobin molecules over here. Diffusion is taking place. Hemoglobin molecules are there. So oxygen plus the hemoglobin will give you oxyhemoglobin. So oxygen molecules over here. Yes. Hemoglobin molecules in the blood, capillary, blood is flowing. Yes, then this diffusion taking place, you can see the arrow. Now this oxygen combines with the hemoglobin molecule, forming oxyhemoglobin molecule. So one hemoglobin molecule can carry 4 oxygen atoms, and it becomes oxyhemoglobin. Okay, and then it will be taken to the tissue. Now in the tissue, you can see over here, this is the tissue, this is the blood capillary. The hemoglobin molecule will give away the oxygen. You can see the arrow downwards, it will release the oxygen, diffusing the oxygen, and now it is free. So now the hemoglobin can be again taken to the alveoli and carry next set of oxygen molecule. Okay, so this type of transport of oxygen from the lungs to the tissue is maximum type. 97% of the oxygen that is given to the tissue is transported via this type. Only 3% of oxygen is dissolved in the plasma of this blood. It is not carried away by the hemoglobin, rather it is dissolved in the plasma of the blood and then taken to the tissue. Understood? So this is very straightforward. Who forms oxygen can be transported? Majority 97, major part of it in the oxyhemoglobin form. You can see the diagram over here, just discussed. Hemoglobin in the RBC, binding oxygen, forming oxyhemoglobin, traveling to the tissue, releasing the oxygen, it becomes deoxyhemoglobin. And the remaining 3% of the oxygen, some of the oxygen molecule get dissolved over here in the plasma of the blood, and then they are transported and given to the tissue wherever required. Okay. One more important factor, which determines this oxygen carrying capacity of the hemoglobin. Okay. Now, if there is more carbon dioxide in the blood, this will result in decrease in the pH of the blood. More carbon dioxide, if there are more carbon dioxide level in the blood, this will lower the pH of the blood. Lower the pH means what? From 1 to 14 you have the pH scale. Okay, and 7 is the neutral. So if you move down towards the 7, you see low, you tell low pH. Yes, and when you go upwards, you say high pH. Okay, this is more acidic, this is more basic. So when there is more carbon dioxide, there will be more H plus in the blood. This will lower the pH. Why we are taking this point out of the sudden over here? Because this low pH will affect the ability of the hemoglobin. Will affect the ability of the hemoglobin to transport oxygen. One hemoglobin takes 4 oxygen molecules. So this will be affected if there is more carbon dioxide in the blood. That means if the pH is low. If the pH is low. So if the low pH is there, hemoglobin, instead of binding oxygen, it will have a tendency to release oxygen. Instead of binding the oxygen, it will have a tendency to release oxygen. Because of this low pH, hemoglobin will, whatever oxygen is bind to it, it will release. Okay, because of this low pH, and this low pH is because of more carbon dioxide. This will result into this curve, with the carbon dioxide in the blood. Okay, this will be the partial pressure of the oxygen. You can see this. And if there is more oxygen, means high pH, okay, then hemoglobin will try to bind, it will try to hold on to the more oxygen. Okay, so it will result into this curve. This is y-axis is telling you percentage saturation of hemoglobin with oxygen. Percentage of saturation with hemoglobin with oxygen. So this percentage of saturation is more when there is no carbon dioxide in the blood, without carbon dioxide. So you can see by the graph plotted over here, if the partial pressure of the oxygen is not that great also, but it is in this range, but it is without carbon dioxide. Okay, then the hemoglobin will bind more to the oxygen. Okay, you can see the shift, the curve shifting towards the right. Whereas if there is more carbon dioxide in the blood and lowering the pH, the ability of the hemoglobin to bind the oxygen will be very less, and that is why it is more towards the left. Okay, so the saturation, you can see there is a significant difference in the saturation of oxygen level in the hemoglobin without carbon dioxide in the blood and with carbon dioxide in the blood. Means your pH is high, your pH is low. This is also known as the pH effect, or it is also known as the Bohr's effect. Okay, so this determines the binding of the hemoglobin to the oxygen. So hemoglobin is transported, as we saw, can be in two forms. Majority is the oxyhemoglobin form, and this oxyhemoglobin formation will largely depend upon the pH of the blood. That is the presence of carbon dioxide level in the blood. Okay, so that's all about the carbon dioxide transport. Moving to the few factors, so just summarizing it. Oxygen transport is favored when alveoli, the condition favor oxyhemoglobin. In the alveoli, hemoglobin will be more in which form? Oxyhemoglobin, because there oxygen is more, pH is high, okay, carbon dioxide is less, so high pressure of oxygen, low partial pressure of carbon dioxide, lesser H plus concentration, okay, and means high pH and lower temperature. Okay, this will favor oxyhemoglobin formation. Whereas in tissue what will happen? Tissue there is low oxygen, high carbon dioxide, high H plus concentration, higher temperature. This will favor the dissociation of oxygen and hemoglobin. Okay, whereas in alveolar, oxyhemoglobin formation will be favored. At the tissue level, dissociation of oxygen from the hemoglobin will be favored. Okay, I hope this is understandable. Yes, so this is all about the oxygen transport. Now we move on to the carbon dioxide transport. Now, carbon dioxide transport is basically in the dissolved form. Majority of the carbon dioxide, whatever is generated in your body, is removed out of the body in the dissolved form. Why? It is not carried by hemoglobin. In the previous video, we have been talking about that hemoglobin can carry oxygen also as well as carbon dioxide. But hemoglobin has very less affinity to carry carbon dioxide. It does not love carbon dioxide that much as it loves oxygen. Okay, so carbon dioxide cannot be taken by the hemoglobin. Majority, it has to be dissolved in the blood and given out of the body through the lungs. Okay, yes. So in the dissolved form, carbon dioxide is given to the alveoli of the lungs and the oxygen is taken in. So when the exchange is happening at the alveoli level, there the dissolved carbon dioxide will convert into carbon dioxide and it will be given back to the alveoli of the lungs and the lungs will give out, exhale out. Okay, from the dissolved form. So hemoglobin, as we are telling, hemoglobin is not liking carbon dioxide that much, but very small percentage of carbon dioxide still hemoglobin will carry in the form of carbaminohemoglobin. In the form of carbaminohemoglobin. Okay. So we are talking about carbon dioxide transport. Carbon dioxide transport can be transported in three ways. Oxygen in two ways. We saw 99%, 98% was in the form of oxyhemoglobin. Here, 20 to 25% of carbon dioxide can be transported by hemoglobin only in the form of carbaminohemoglobin. Similar, like hemoglobin binding to oxygen, resulting into oxyhemoglobin. Here, hemoglobin binding to carbon dioxide, giving what? Carbaminohemoglobin. Carbaminohemoglobin. So 20 to 25% of the total carbon dioxide in the body can be transported via this type. Another majority, 70% of the carbon dioxide is transported in the form of bicarbonate ions. HCO3 minus. Okay, dissolved form. This majority of your carbon dioxide will form this, and then it will be converted to carbon dioxide and then it will be removed out of your body. And the last remaining 7% will be in the state of dissolved state in the plasma. So they will remain in the state dissolved state through the plasma and then they will be converted into carbon dioxide and removed out of the body. So majority it will be through bicarbonate ions. Okay, this is very simple. We need not discuss more about this because it's the same like hemoglobin binding oxygen giving oxyhemoglobin, hemoglobin binding carbon dioxide giving carbaminohemoglobin. So that way it can be transported. Now we will focus more on this 70% of the carbon dioxide which is getting transported in the form of bicarbonate ions. So how this is how bicarbonate ions are formed and how from bicarbonate ions carbon dioxide will be formed, converted and then given to the lungs and then lungs will exhale it out. That we have to see in detail in the coming discussion. Okay, so I hope it is understood till here. So the binding of the carbon dioxide and oxygen is due to the partial pressure. So this, as we were discussing, the question might arise in your mind, how come carbon dioxide is also binding and oxygen is also binding at the same time? This will largely depend upon the pressure. So if carbon dioxide partial pressure is more, carbaminohemoglobin will form. If oxygen pressure is more, then oxyhemoglobin will form. So at the alveoli level, mostly oxyhemoglobin will be formed. At the tissue level, carbaminohemoglobin will be formed more. Okay, because here the carbon dioxide partial pressure is more. So this binding will depend mostly on the partial pressure. Okay, so I just said carbon dioxide is high at tissue level, thus carbaminohemoglobin is formed, and at partial pressure is high at alveoli level. So over there, oxyhemoglobin will be formed. Okay, so now moving to the most 70% of the bicarbonate ion. So how that will be for I mean how bicarbonate ions are formed and that will be transported. So mostly carbon dioxide is transported for exhalation as we just discussed in form of bicarbonate. This will be formed in your RBC only. RBC only. Okay, the erythrocytes. So most of the carbon dioxide that is in here that is produced in the body after metabolic activities. So it is exhaled out of the body mostly in the form of bicarbonate ions, which is formed in the RBCs, that is the erythrocytes of the red blood cells. Okay, so how this carbonate ion is formed? Basically, if you see the reaction which is there on the screen, okay, so they are formed by uh, combining of carbon dioxide with water. So bicarbonate ions are formed by the dissociation of the carbonic acid, which is formed by the combination of carbon dioxide and water. So what happens first? Carbon dioxide, that is the gas which has to be removed out of the body. This carbon dioxide plus water, okay, they will combine, they will form carbonic acid, then this carbonic acid dissociates, okay, it gets separated, the H plus separates and the bicarbonate ion separates. If you remove hydrogen ion from this, you are left with only one H and CO3 minus. This is your bicarbonate ion. So the carbon dioxide is trapped in this. So the carbon dioxide will be released from this bicarbonate ion, and then it will be in the form of carbon dioxide. It will be taken by the lungs, and then through exhalation, through expiration, the carbon dioxide will be given outside. Okay, so this is how the carbon dioxide transports, which account for 70% of the transport of CO2, will take place in this manner. We discussed it will take place in three manner. First, 20 to 25% will be in the form of carbaminohemoglobin. Second, mostly 70% of it will be transported via this. So carbon dioxide and water combination will be brought about by an enzyme known as carbonic anhydrase. Okay, carbonic anhydrase. So this enzyme will combine carbon dioxide, water, will form carbonic acid, then carbonic acid will dissociate into H plus ion and bicarbonate ions. Okay, now how this bicarbonate ion is transported in the form of carbon dioxide to the lungs. So this is happening at the tissue level. So from the tissue, the carbon dioxide is taken in the red blood cell in the RBC combined with water, and this is the reaction. Then what happens, as and when the blood is taking up, the RBC is taking up the carbon dioxide, these reactions are happening at a faster rate. So what is happening? Bicarbonate ion level will start to rise in the RBC, right? So more and more bicarbonate ions will be formed. So what happens? The RBC it gives out carbon dioxide and takes in chloride ions. Okay, as you can see in the figure. Yes, so this is the combination. This is a reaction that we saw just now. Yes, carbon dioxide and water forming H2CO3, and then H2CO3, that is the carbonic acid, dissociating. This can go and bind with hemoglobin. Now, as and when HC3 CO3 minus, that is the bicarbonate ion level, increases in the red blood cells, that is the erythrocyte, what happens? The automatically, naturally, this the phenomena of chloride shift happens. What is chloride shift? The bicarbonate ion will exit the RBC, and in that place Cl minus will come to maintain the ion balance. Okay, so it is exchanged with the chloride ions as and when it is passing, as the blood is RBC is passing through the through the membrane into the plasma by a mechanism known as chloride shift. So what will happen? CO3 minus will come in the plasma. This is the plasma, and the Cl minus in exchange of HC3CO3 will go into the RBC to maintain the neutrality so that there is no disturbance in the ion charges in the RBC. Okay. Yes. So first step, carbon dioxide taken from the tissue to the combined with water. Yes, in the form of in the presence of enzyme carbonic anhydrase, carbonic acid is formed. It dissociates into bicarbonate ion. Now, as the bicarbonate ion level increases, what will happen? It will come out of the RBC in exchange of chloride ion. Now, this bicarbonate ion is in the plasma now. What will happen to this now? As the blood is following, so carbon dioxide is taken from the uh, lungs and sorry, it is taken from the tissue and it is taken to the lungs for exhalation. Now what happens at the exhalation? You can see over here, same reaction will happen but in the reverse direction. Same reaction will happen but in the reverse direction. Okay, now you can see there will be re-entry of HC3CO3 minus. So when the blood or when the whole thing reaches the alveoli, that is near to the lungs, near the alveolar wall, so that this carbonate ion now has to be turned into carbon dioxide and removed out of the system and give it to the lungs, and the lungs will take it outside through exhalation. So there will be re-entry. You can see the arrow giving direction over here. So this bicarbonate ion will re-enter. Okay, then it will bind with H plus again, which was released from the hemoglobin in the red blood cell. It will re-enter in the RBC. So from the plasma, it will go into the RBC, combine with H plus. Carbonic acid will be formed. Carbonic acid, with the help of the same enzyme, will now form water and carbon dioxide. Same reaction will happen in the reverse direction. The reaction which we saw in the previous slide, same reaction but in the reverse direction. Okay. So this will happen, and then now this carbon dioxide will diffuse in the alveoli, and then through exhalation it will be given out. Simple to understand. Okay, so step by 3 steps, that's it, nothing more in it. So bicarbonate ion will re-enter the RBC in exchange for the chloride ion in the pulmonary capillaries. So here the blood vessel that we are talking about is a pulmonary capillary, basically the ones which return carbon dioxide to the lungs for exhalation. This reverse reaction will happen with the same enzyme carbonic anhydrase and thereby forming carbon dioxide and water. At the tissue level, same reaction is happening. If here there was tissue, so at the tissue level, same reaction will happen but in this direction. And at the lung level, alveolar level, same reaction in the reverse direction. So that's the only difference. Okay. In this picture, you can also see the whole summary of it. Number 1, carbon dioxide dissolved in plasma, that is 7% of total carbon dioxide is dissolved in the plasma and then returned in this manner. Mostly it is transported in this manner, and remaining 20-25% in carbaminohemoglobin form. Okay, so this is how the carbon dioxide will be transported from the tissues to the lungs. Okay, so the carbon dioxide will diffuse out of the RBC into the air through the respiratory membrane. Okay, this is the summary of the whole oxygen and the carbon dioxide transport. You can go through it. It is written in nicely step-by-step manner. We have discussed it in very much detail. Okay, so the reactions are also given, numbered, and the steps are also given. This is the summary I have included for you to go through at the end. You can take help of this and make your own answer with these pointers. One of the very important questions to be asked in board exam, exchange of gases of carbon dioxide and oxygen at the tissue and the blood level. Difference between is also asked. So you can prepare the topic accordingly. So gas exchange at the tissue level. See, if you see the reaction, both the reactions are the same, but it will occur only in reverse manner. That's the only difference. Okay. So from the tissue, carbon dioxide diffuses into the plasma. Carbon dioxide enter into the RBC. Water combines. Carbonic anhydrase is the enzyme. carbonic acid is formed. Then this dissociates into H plus ion and bicarbonate ion. Now bicarbonate ion, as and when it increases, it exits the RBC. Chloride comes in place of that. Okay, this H plus is required for hemoglobin binding. Yes, the same thing is for carbon dioxide. What happens to oxygen? Hemoglobin has affinity to bind to carbon dioxide also, oxygen also, and it picks up as and when it is dropping oxygen to the tissue, because it is bringing oxygen from the lungs and giving it to the tissue. Now it is empty. The seat is empty. Carbon dioxide pressure, partial pressure is more over here. So carbon dioxide can also bind over here. So some of the carbon dioxide will bind, and carbaminohemoglobin will be formed. Okay, so this is happening at the tissue and the red blood cell level. The same thing, the same reaction, the only difference is now here the alveoli is there. Okay, the same reaction but in reverse order. As you can see over here, the arrow was downward in the previous slide, now it is upward. Okay, so oxygen will be taken in the plasma, enters into the RBC, binds the hemoglobin, carbon dioxide is diffused. This carbon dioxide is in the red blood cell in the carbonic acid form. Then with the help of the enzyme, this is split up into water and carbon dioxide, and then carbon dioxide is released over here, and then this is diffused again in the alveoli for exhalation to take place. Okay. So go through it. If you face any difficulty, let me know. You can reach out to me to ask your doubts. Make a note of all these things, and then you will be good to go. So that's all for this video. In the next video, we will be talking about the involvement of regulatory signals in the control of respiration. Okay, that is regulation of breathing. So that's it. Thank you. Take care. See you in the next video. Bye bye.